Hey everyone, hope you're doing good. So welcome to another video. In this video, we are going to understand what is RAG. So we'll go through a basic definition of RAG. Definition of RAG. Then we are going to understand, why should you use RAG in your applications. Then we are going to understand a basic pipeline to build RAG, as in what are the features of this pipeline, and then we are going to go through a working example. So stay with me through the end of the video, wherein till end we'll understand the end-to-end definition of RAG, and we will also sort of chunk a personalized data into the vector database and try to retrieve the personalized information which is only present in that document. So yeah, let's start. So yeah, what is RAG? So I have pulled out a basic definition of RAG. RAG is Retrieval-Augmented Generation, is the process of optimizing the output of a large language model so it references an authoritative knowledge base outside of its training data source before generating a response. The keyword over here is optimizing the output of a large language model. So we all know that large language models are trained on a particular data set which is constantly evolving, right? So if today you are going to ask a large language model that who won the US Open yesterday, it will not be able to answer you perfectly because it has not been trained till that data. Also on a very specific data set, the RAG will have the large language model will have problem responding to your queries, because it will always give a sort of generalistic response. So what RAG does is RAG sorts of precises the response from the large language model by and in a way optimizes the output of a large language model so it references an authoritative knowledge base outside of its training data source. So this is an additive knowledge database that is being accessed by the large language model other than its the response from the LLM itself. So yeah, this can be called an additional database. So here we can understand that this is the query is being placed to an LLM. Now LLM can this is the simple pipeline. The you as a user will place a query to the large language model and it will give the response, correct? Now when RAG is enabled, what it does is it is able to sort of extract the information from a particular database. That is what is being said here, and which is called RAG. Now and then it is used to optimize that query. We are going to understand the pipeline in detail, but yes, this is what is being done over here. So it optimizes the response of the large language model. Then again, what further it says is, large language models are trained on vast volumes of data and use billions of parameters to generate original output for tasks like answering questions. RAG extends the already powerful capabilities of large language models to specific domains or an organization's internal knowledge, all without the need to retrain the model. So if a particular application is being used in an organization, right, and I have used this example in the video ahead, wherein the organization, the employees need to know what is the policy of the organization on a certain topic, right? So if you are going to integrate for that organization, if you are going to integrate a simple pipeline that you are going to place a query to the large language model and you are going to respond. So say I work in an organization, say Airtel, right, and I ask the large language model what is the policy of leaves for Airtel employees. So it is going to give a very generalistic response. So we can do that over here also, we can check it. Okay, what is the policy of leave for Airtel employees? Okay, so basically it accesses the internet and provides me the information that okay, Airtel provides 26 weeks of paid maternity leaves, in addition returns and everything that it has found on the internet. Perfect. Now, as an employee, this information might not be really correct for me, because everything is not reported on the internet about the policies of an organization, right? It is a very internal document that is accessed by the employees only. So what we enable through RAG over here is to access the internal document and to return the query of the user in a particular way. So yeah, why do we use RAG? Because obviously one is to reduce the hallucinations. Now to sort of guardrail the response, we use RAG. Then we can always query that there are other modes of optimizing and large language model, which includes fine tuning a large language model, right? But a lot of times we see that this is very costly. The fine tuning process is very costly, and it takes a lot of times it takes months to fine tune a particular large language model, and it might not be financially viable. So in that case, RAG is a sort of way around wherein it allows the large language model to access the information. Then as we discussed, we can always give the domain specific knowledge to RAG and access it over here, and the dynamic information which is constantly changing. So we can always change the policy documents, or we can always change the information documents in the RAG, so that the large language model is able to access it, and in a way the information is updated, which is why it is called a dynamic information update. Okay, now coming to RAG pipeline. So if we are going to understand the RAG pipeline from an overview or from a bird's eye view, we understand that a RAG pipeline has two major parts. The first is data ingestion part, and the next is data retrieval. Now data ingestion means how we are actually going to ingest the data into the vector database, so that it can be retrieved by the large language model. So the data ingestion parts looks at actually pushing the data into the vector database, and retrieval parts is about retrieving the data in a very contextual form through the large language model from that database, right? Now what is so first we are going to understand the data ingestion part. Data ingestion means you are going to ingest the data into the vector database. Now this whole part is the data ingestion part. Now if you are going to ingest the data, right, in this from here to here, so how are we going to do that? So first, in what form is the data available to us? So the data is available to us in the form of PDFs, right, in the form of Word documents, in the form of other documents. Now how does this ingestion takes place is that first we are going to pre-process the data. Now what does pre-processing of data means is that we have these PDF, Word, etc. files. We are going to clean those files. What do you mean by cleaning those files? That we are going to probably remove the headers, put it in a metadata form. Now this is a very dynamic field wherein based on your applications you choose it, or based on the type of file that you have, you choose it to do it in your own format. Then the next step comes is the chunking of data. What is chunking? Chunking is data is broken down in manageable chunks for embedding. Now so say you have a particular MD file, right, MD file that you need to chunk it to the embedding model. So you can choose to chunk it in the form of by splitting each character, if that is useful for you, or splitting the chunks basis the token counts. In a lot of times the chunking is done based on sentences. So again, this is a very dynamic and very argumentative topic, which is specific to each of its own use case. So basically if you have a whole line of data, what you do is you will probably divide it in various chunks and send it in the embedding model. Another way of pre-processing of data is metadata enrichment, wherein you add metadata to the documents so that it is better understood by the embedding model. Now, when we push this data to the embedding model, there are again a lot of methods in which this embedding can be done. So basically, what is embedding is that you give a particular place, to the chunks in the vector database. Now, vector database is a three-dimensional space. Understand it like a three-dimensional space, and this. Now, based on certain embedding logics, the chunks will occupy a particular position in this database, right? So probably say a chunk occupies over here, a position over here, then another chunk occupies a position over here, right? Now, first we'll stay to the embeddings and understand that in a word embedding, what is a word embedding? A word embedding is wherein each word is a vector. So probably say you have each word which are organized as a vector. Now, contextual embeddings, what happens is that words get different vectors based on context, and this is what we will be using for our example as well, and it is a very fruitful method of searching the contextual data. Now, if you want to understand the contextual embedding, let us take the example of say a particular sentence which is also in context, sort of related to another sentence as well. So I have written it over here. So contextual embeddings help in the semantic search, right? Now say we have an embedding which says plants make food, and the other embedding is photosynthesis produces glucose in leaves. Now, when this is done as a contextual embedding, what happens is that these two vectors will be placed close to each other, right? This will be placed, these two vectors of plants making food, of plants making food and photosynthesis produces glucose in leaves, right? These two vectors will be placed very close to each other, so that when they are retrieved, the distance between these two vectors is less, and when they are retrieved in the particular context. So these both will end up with vectors close to each other in the embedding space, and hence during retrieval the context of both these statements. So say retrieval is done for photosynthesis, right? So context of both these statements will be taken. So this is how the contextual embedding helps in contextual referencing of documents. So this is the embedding that we have used for our document in the example. Then there are sentence document embeddings, multimodal text images embedding for different kind of data, and then domain specific embeddings for specialized use cases, which we will not be covering over here. Then vector database is actually the space wherein these embeddings are stored. So for our example, we will be using the memory based vector database only, but for a production or for a development environment, a lot of times these free database can be used, which is provided by Chroma and FAISS, which can be used in local production, or if you want to go with a higher production environment, a Pinecode and VV8 are used for these kind of embeddings. Okay. Now what happens is, so this is the data ingestion part. Now the second what happens is, you are also embedding the query that is being placed by the user in the embedding model to retrieve the context or the semantic search. Now this is a very important part. So initially, a person can be of the understanding that yes, the data is being pushed into the vector database, but it is then retrieved, and the LLM is going to give the query plus context response to the user. But if that is not the case, even the query gets embedded, and then in the vector database a semantic search is performed. Now again we'll be this what is semantic search is that semantic search searches for two data points which are sort of close to each other, which helps them build a context and then retrieve the information in a particular way. So, and in a lot of e-commerce search engines, this kind of search is used. So probably when you are checking out with a cricket bat, so semantic search will tell you that you might also require the ball, or you might also require gloves or other parts of the cricket kit, right? So this is the context searching in semantic search. So basically what happens is, again these two data points are placed close together and then they are retrieved. So for this, the query also needs to be embedded into the data into the vector database where this semantic search happens, and then basis this semantic search, a context is being provided along with the query to the large language model, which then proceeds and processes the query and responds to the chatbot, and then the user is able to retrieve the information. So this is the complete understanding of the RAG pipeline over here, where the data is first ingested into the embedding model. It is held in the vector database. From there, the LLM retrieves the information, and then it is passed to the user. Now we'll move to the working example of how this actually works in a Jupyter file, and we'll take the same example of the internal policy document, and try and understand that how this RAG actually works. Okay, so we are going to understand how a simple RAG pipeline works through this example that I've built in the Jupyter environment. This has been inspired by this article of build an retrieval-augmented generation app in the LangChain. So you can access this at any point of time and understand how this is actually built. What I have done is I've basically tweaked with these commands to put in my source of the PDF that I am wanting to chunk, and then retrieve the information from here. So initially, again, the requirements, I have fetched the requirements from this environment. I have installed the LangChain dictionary, and then what I have done over here is then again provided the key for retrieving the response from OpenAI. So here I am using GPT-4o mini, and with the model provider is OpenAI. Again, these are pre-context setters that is being defined for obtaining a response from the large language model. Now here what we have done is we are using text embedding 3 large model of OpenAI, wherein we are going to embed the document based on text embeddings that we are doing it over here. And in the vector stores, we are storing the vector stores are in memory vector store. That means that what we saw over here is because we are only showing it for an example, right? So the vector DB over here is the in memory vector store. That means as soon as the flow is completed, it is deleted. So yeah, that is how it is. The next step is basically I have built 2 directions of it for our understanding. The first is that I am chunking the document and retrieving the information, and the second function I have built so that I am retrieving a generalistic information from the large language model. Okay, so what I have done over here is I I have given a file path. So this file path is of a particular is of a particular policy document that I have designed. Let me see if it is open. Okay, it is. Where is it? Airtel benefits, right? Yeah. So this is the policy documents I have designed. Again, this is for probably the employees who are working at Airtel. So I have designed a dummy document wherein I have mentioned various benefits of working at Airtel, right? Now what I am doing is I am loading this through PyPDF and then using the recursive character text splitter method to actually sort of chunk these documents and embed it into the vector embedding. So the chunking of the documents, like we saw over here, was the pre-processing of the documents, and then we are embedding it, right? So again, through text splitter, recursive character text splitting, I am chunking these documents, and then I have added these documents into the vector store. Now again, the vector store over here is in-memory vector stores, which stores the embeddings, right? Now I am giving a prompt. So again, this is orchestrated in LangGraph. If you want to understand that, how the agents are orchestrated and how the classes are set up in LangGraph, you can go through the documents in LangChain to I'll just show you. Orchestration. So basically you can read these documents over here. Orchestration agent, right? Yeah, so this is how you basically build a basic chatbot, and everything is explained over here, that how you use this orchestration to build an agent. So I have using the same framework to build this, wherein I have set up a state class and then defined the application. What I am doing is I have chunked the documents, and then after that I am retrieving the context from the vector store over here, and then when I am generating the response from the LLM, so response is equals to LLM.invoke. So when I am generating this response, what I am doing is I am invoking the message which has the question, that is the question from the user, along with the context. Now this context has been retrieved from the retriever agent, which is again this part over here, wherein the similar contexts are being retrieved from the vector database, right? So then basis that we are generating the response, and also I have crafted a second agent wherein there is no context that is being retrieved, to sort of build a comparison between the two responses that we get. What is the question that I am asking is, I am asking a very pertinent question: what is the flexible leave policy at Airtel? Now in the document, if you go, you understand that this is the document that I am chunking, and here in this document the flexible leave policy is being mentioned. So in the flexible leave policy, it is mentioned that take up to 38 leaves each calendar year, so you can spend time with the family. These are segmented into 8 fixed holidays and 30 flexible leaves, right? So say this is incorporated in Airtel, this application is incorporated in Airtel, and the interface is with the employees, wherein the employees ask, hey, what can I do? What is the sort of flexible leaves that I can avail, right? Now if you are going to not include the RAG and simply pass this in the without any context, what will happen is you're getting a very generalistic response over here, which, like I showed you there, it is flexible leave policy allows employees to manage their leaves in a way that suits their personal and professional needs. This policy typically includes paid leaves, casual leaves, sick leaves, etc. But obviously it is not giving the context as per the document, my policy, internal policy document, which is take up to 38 leaves each calendar year, and these are segmented into 8 fixed leaves and 30 flexible leaves, which is the information that actually I want to know as an employee, right? So but then again, when we use the RAG and when we enable the large language model to have access of the RAG, what happens is that it generates a response which is very pertinent in based on this document. So I have passed in this RAG, I have run it, and then basis that I am generating this response over here. Yeah, so the response comes: at Airtel, the flexible leave policy allows employees to take up to 38 leaves each calendar year. That is what I want to know, which is 8 flexible holidays and 30 flexible leaves. This can be utilized at the employee's discretion. These are predetermined and consistent each year. Additionally, in case of emergencies, the employees can borrow up to 10 leaves from the next year's leave account. Now, this is what semantic search means, that here it is mentioned that during emergencies borrow up to 10 leaves from the next year's leave account. So this is also mentioned in the context and responded to the employees in this way. So that explains why RAG is useful, and why how it provides the complete context through the documents and enables the large language model's response to be more precise, less hallucinations. It is a better alternative than fine tuning the application, and it also serves the purpose of including dynamic information into our responses that is being generated by the large language model. Hope you had a good session over here. If you have any queries, please let me know. I'll try and come back to those queries in the YouTube comments, and I'll also attach the references that I've used over here for your better understanding. And yeah, keep watching. Hopefully you are going to subscribe and share the video, and thanks for joining in. Thank you.